start with the 28th example, in which multiple pulleys are present and movable pulley is also present. So let's do it with the help of some shortcut. Here if I say tension in the string is T, then in this string it will be 2T. That is very clear from the diagram. Now the value of tension T will be equal to the coefficient of T into G plus coefficient of T into G plus coefficient of T into G for all suspended blocks. So for this block, coefficient of T is 1 into G. For this block, coefficient of T is 1 into G. Coefficient of T is 2 into G divided by coefficient of T square upon mass. So coefficient of T square upon mass 3 plus coefficient of T square upon mass 2 plus coefficient of T square upon mass, this one, 1. So now in the numerator it becomes 1G plus 1G plus 2G, so that becomes 4G divided by 1 upon 3 plus 1 upon 2 plus 4 upon 1. So here you can see the LCM is 6, and in order to get 6 in the denominator, I am multiplying it by 6. I am multiplying this by 3, and I am directly multiplying this by 6. So that comes out to be 24 into G upon 29 Newton. That is the value of tension T in the strings. Okay. Now this becomes quite easy. Once you get the tension, then you can find the acceleration of each block by drawing just its FBD. For example, if I draw the FBD of block of M1 of mass 1 kg, so its weight is acting in the downward direction 1G, tension 2 into T, that is 48 G upon 29 acting in the upward direction, which is greater. So obviously block 1 will go up with some acceleration. So acceleration will be equal to net force upon net mass, which is 1 kg. So acceleration would be equal to 48G minus 29G divided by 29G. So acceleration would be equal to, okay. And now we just have to subtract 48 minus 29. So 18 minus 9 will be 9, and 3 minus 2 would be 1. So that comes out to be 19G upon 29. That is the acceleration of the first block. Similarly, by drawing FBDs, we can find the acceleration of second and the third block quite easily. Okay. So let's find the acceleration of second block. Its weight is acting in the downward direction 2G, and tension is acting in the upward direction for block 2. That is M2 block of mass 2 kg. So tension T, that is 24G upon 29, which is less than 2G. So that's why it will be going in the downward direction. So the acceleration would be equal to net force 2G minus 24G upon 29 divided by mass 2 kg. So A2 comes up to be, this 29 will go there, and this becomes 58G minus 24G upon 2 into 29. So directly again I can say 58G minus 24G. So 8 minus 4 will be 4, and 5 minus 2 will be 3. 34G upon 58, and that would be the acceleration. We can reduce it. That is 17G upon 29. That is the acceleration of the block 2. Similarly, by drawing the FBD of block 3, so this is our block 3, and I am drawing the FBD of block 3. Its weight 3G is acting in the downward direction, while its tension on it 24G upon 29 is acting in the upward direction, which is greater than 3G, so it is going in the upward direction. And the acceleration of third block can be easily found by the same method. So I can directly write the acceleration of third block here, that A3 is equal to 21 upon 29G. So that would be the acceleration for the third block. Okay, while in the downward direction, because 3G is greater than this thing, so it will go in downward direction. This is also going in the downward direction, while this is going in upward direction. Now we have calculated the accelerations of block 1, 2 and 3. How long will it take before m1 strikes the pulley. So it is said that when m1 will be going to strike the pulley, so already it is given that the length of block to pulley, the length of block to pulley is given to us, that is 20 centimeter. So after starting from rest with an acceleration of this one 19g upon 29, how long it will take to get displaced by 20 centimeter? So in that case we will use equation of motion. See, S is equal to 20 centimeter means 0.2 meter displacement is equal to ut plus half at square a into t square, and on solving we will get the value of t, which is 0.25 second approximately. Thank you.